All right, let's look at this example 103. On these, we're plotting similar things to what we did before, but now we're mixing the sines and cosines together. Um, let's see, we've got cosine t and sine t. If we look at that, before we graph it, let's look at what's happening. So we've got cosine and sine. So cosine is going to do this, and sine is going to do this. Drew a little extra there. Sine is going to do that. So if you look at what happens, we're going to start out with our x-coordinate being 1 and our y-coordinate being 0. And then by the time we get up to 90 degrees, cosine, or x is going to be 0 and y is going to be 1. Basically, this is the definition of the unit circle. X is cosine t and y is sine t. So when we graph this, it's no surprise that we get the unit circle out of it. And if we put a coefficient in here, say a 2 there and a 2 there, we still get the unit circle, but when we go from 0 to pi, so you're right here below pi, we've made almost a complete revolution. So we make one trip around the circle of pi, and since we go up to 2 pi here, that makes 2 trips around the circle. And the same thing happens if I put something else in here, like 3's. We make it all the way around the circle right as we get to 2 pi over 3. So that makes 3 trips around the circle. You can see this a little easier if we look at this this over here where we can watch the point move. So if I put sine of 3t and cosine of 3t, it's going to make 3 trips around. All right, what are the other things we have over here? We had cosine and sine, which gave us the unit circle. If we swap sine and cosine, we're still going to get the unit circle, but instead of it traversing in this direction, it's going to traverse it in the opposite direction. So let's go back here and do it. I'm going to change this to sine, and this to cosine. And I've got a 3 there, so going from, when b goes from 0 to 2 pi, this is going to make 3 trips around the unit circle. But it's going to do it in the opposite direction. And it's going to start, since sine is now my x, it's going to start at the point 0, 1. See, it starts at 0, 1 up there at the top, and then it's going to go around. All right, I've actually got a typo here. This should say x is sine ct, and actually one of these should be cosine. It doesn't much matter which one. I'm going to change this one. If we look at cosine, let's see, cosine of 3t, sine of 3t, we get the unit circle there. But something neat happens if we change one of these numbers. We change that back to 1, we get this. These shapes are called Lissajous functions. It's a Lissajous, Lissajous functions, and they're fun to play with. So let me pick 2 numbers here. 3 and 6, that gives us the same thing that we would get with 1 and 2. So let's pick 2 numbers that are relatively small but are also relatively prime. So let's go with 2 and 5. If you look at this graph now, the let's see, my pointer's not showing up. Let me change this. Okay, my pointer's showing up on here. If you look at this, x is a cosine 5t. So if you look at this, we've got 1, 2, 3, 4, 5 different peaks, I guess you'd call them, on this side, and 5 over here. If I change this 5 to a 3, now we've got 3 on each side. 1, 2, 3, and 1, 2, 3. Now, if I change this, let's change it back to a 5. And let me get this on screen a little better. If I change that to 5, over here on the sign, we've got 2 peaks. They don't really look like peaks because they're so flat, but there's like a maximum value here and a maximum here, and there are 2 of them. If I change this to 3, we'll get 3 there. If I change it to 4, we'll get 4. If I change it to 5, now we're just back to a circle because it's not really the 2 numbers that matter, it's their ratio. If I change it to 6, then we'll get 6 little peaks across here. 1, 2, 3, 4, 5, 6. And then again down the side we've got 1, 2, 3, 4, 5. And you can do some pretty crazy stuff here. Let's make this 11. This one over here, if I make it 13, we get this, fun shape. I'm gonna bring this back over here and I'm gonna animate this. We can see it draw the whole thing in. So I don't know, to me they're aesthetically pleasing. Let's put in, okay, let's do something crazy and then we'll do something else. If I put in 99 there, if I put in, say, 33, we get this. Now, if I try to draw this, notice every time I go through just a little bit, I only have to go very short way to get the whole thing.